Hi, this is Arthur with Achieve Educational Opportunities, and today we're going to learn how to calculate the Wronskian of a set of functions. The Wronskian is a tool to help us gather more information about the solutions to our differential equations. The Wronskian is a simple tool used to find out more concise information regarding the solutions of differential equations. By using an algebraic approach combined with derivatives and following the conditions established on each differential equation's case, the Wronskian can let you know the final solution of the problem. One of the greatest advantages of the Wronskian is that it can be used with higher order differential equations. And so, for any nth order differential equation, as long as you have n minus 1 solutions, the Wronskian will aid you in solving for the last general solution while adding information on the rest of them, such as linear independence, plane location, etc. When we compute the Wronskian of the two functions involved in the preliminary solutions, and the determinant result is different from 0, then we know we have a fundamental solution for our differential equation by adding the two preliminary solutions. Once a fundamental solution for a problem has been found, the numerical solution can be easily obtained, and you can be sure that the result is going to comply with your original boundary conditions. So let's take a look at how to do these things. We want to calculate the Wronskian of the indicated set of functions and classify each set of functions as linearly independent or linearly dependent. So we're going to take a look at the set of functions S is equal to the set t and 4t minus 1. To calculate the Wronskian of S, which is the Wronskian of the set t and 4t minus 1, what we do is we take the determinant where our first row is going to be the two functions themselves, and the second row is going to be the first derivatives of those functions. So the first row of our matrix is going to be t, the second element, 4t minus 1. The bottom left element is going to be the derivative of t, which is just 1. The bottom right element is going to be the derivative of 4t minus 1, which is just 4. Next, we compute this determinant. We have a times d minus b times c, which is 4t minus 4t plus 1. So the Wronskian of this set of functions is 1. And this is useful because since we know that the Wronskian of S does not equal 0, our set of functions rather, S, is linearly independent. So let's take a look at one or two more of these. Next, let's look at the set of functions S is equal to the set e to the minus 6t and e to the minus 4t. So, the Wronskian of S, which is the Wronskian of the set of functions e to the minus 6t and e to the minus 4t, is computed by taking the determinant, which in this case will be e to the minus 6t, e to the minus 4t. Down here we have the derivative of e to the minus 6t, which is just negative 6 e to the minus 6t. Down here, the derivative of e to the minus 4t, which is minus 4 times e to the minus 4t. To compute this, we multiply these two elements together and subtract these two elements multiplied together. So we're going to have minus 4 times e to the minus 10t plus 6e to the minus 10t. This is a plus here because we are subtracting a negative. We can add these together since they have the same exponent, and we get 2e to the minus 10t. The Wronskian of S does not equal 0. Therefore, the set of functions S is linearly independent. Okay, and let's do one more just to really drive this concept home. Finally, we have the set of functions S with the function t and the absolute value of t. So, in this case, the Wronskian of S, which is equal to the Wronskian of the set of functions t, absolute value of t, will be computed by taking the determinant with elements t, absolute value of t, and then their derivatives beneath them. The derivative of t is 1. The derivative of the absolute value function is the absolute value of t divided by t. Okay. So in this case, we have two submatrices, T1, which we compute as t minus t, or 0. Down here, our other submatrix is going to be t minus t, 1 minus 1. And we're doing this because of our absolute value function. Again, we have minus t minus t, which is going to give us 0. So this first submatrix was for the interval t is greater than or equal to 0. So this will be for the interval t is less than 0. Okay. The Wronskian of S on either interval is 0. Therefore, the set of functions S is linearly dependent. And that is how you calculate the Wronskian of a set of functions which could be used to give us information about the solutions of differential equations. Thank you so much for learning with Achieve Educational Opportunities, and we'll see you on the next video.